One of the most common questions and issues we encounter here at Trotec is people asking the settings for a particular material they are working with. But the truth is, most of the time we're making an educated guess because everybody's scenario is different. The material composite, the power of your laser, the lens you are using could all play a factor in determining your parameters. So the best way to find the perfect parameters is you testing it for yourself. In this video, we will be discussing the job control material database, how to use the database, and how to document your parameters. Let's begin. Let's open up job control and open up the material database. To do so, you could double click on the plate and that would open up the database. You can also do so by finding this icon located at the top, right beside the gear icon. So once we have the material database open, we're going to go over to our left-hand side where all the material settings are located. As you can see, there are settings that are tested with Trotec materials and other basic materials such as paper, metals, and plastics. But please keep in mind that the materials that we tested on is most likely different from the materials you are working with. So these are good settings to use as a baseline or as a place to start. So the Trotec settings are tested on Trotec materials, and we have two settings that prioritizes quality over or prioritize speed. You can also create your own material, which is one of my favorite features in the material database. So if you click on a blank spot, right click, create group, we can create a new group. Say, let's have a group for clients, and under group, we can create another one for a specific client, say Bob's Burger. So let's say we want to make wedding cards on white paper that Bob provides us or we provide. We could put in, some description, white cardstock, and we could define the settings. So say for black, we could engrave 25 power and speed. We could assign red outline as a cut. We could, assign essentially 16 different settings because we have 16 different RGB values. As you can see, if we hover our mouse over the color, it will give us the RGB value. We can also provide the RGB value attached to a document. You can also determine how many passes you want. So if you want to engrave, say, a letter T twice, you could by doing passes. Most oftenly, you want it to be one passes to reduce the time. Z offset would raise the bed up or down. This depends on the application. And most of the time, when you're engraving, you want the air assist off. The direction determines if you want the engraving to start from top to bottom or bottom to top. And in advance, you could play with the correction. So if you find that your corners aren't cutting through, you might want to increase your correction. Or if your corners are tending to burn more, you want to reduce the correction. Links is a feature where it creates hash lines instead of hashes. This is good for packaging. High quality mode is good for engraving, so the laser head will travel across the whole artwork rather than the area that it's supposed to engrave. I won't go into too much detail because we covered it in our job control basics that you could take a look at. So once we have, say, the perfect parameters for Bob's wedding cards, white cardstock. So I have this completed and I'm good to go. Let's say I walk away from the computer and someone else comes in and overrides my perfect settings. Say they're doing something else. Say they're cutting acrylic and they're overriding my settings. Now, all my hard work for Bob's Burgers wedding card is gone because someone came and override my settings. This is quite common if you have one central computer shared amongst multiple users. To prevent this from happening, there's a cool feature. If you go to the bottom left corner, and you can lock it by set master password. So I'm going to create master password, which is set. Now, once you set a master password, you're in admin mode. You're the admin. I'm the only person who have access to the admin. And what I can do is I can lock it. I can lock the settings, and I can switch back to normal mode. So this will prevent anyone going back to switch your settings. You can't touch it. So Bill, John, or Bob can't walk in and change the settings. It is fixed. So these are my favorite features for job control material database and the most useful. So how do we actually use these matrices to test on your materials? So let's do an example, a made-up situation where we want to create a test cut matrix on Trotec 5mm maple wood. So I'm going to go back to job control and check the suggested parameters in the material database to see what are the recommended parameters. So over here on the left-hand side, I'm going to look for solid wood. And here we go. There is a setting already, 5mm maple. So I'm going to use this setting as a guideline to pick my matrix. So right now they are suggesting me to use a power 100% at a speed of 1.4 with hertz at 1000. So let's go back to our file and look at the matrices and see which one best matches the suggested settings. So number 6 looks like it matches what we're looking for. The intervals are using high power cut values. And I believe this will give me the most information out of all 3 matrices. You can also use the general test power cut test settings. This is good to see what will happen if you use a low power, a medium power, or high power. It's very experimental, and it's good to experiment to see what would happen to your material. This is a low interval power cut setting is good for thinner materials like trolleys, cardstocks, fabrics, and so on. All right, so now that we have our intervals, so 51, 54, 53, and it increases by 3, I want to actually set the parameters before I send the file. So to do so, I'm going back to my material database. I would highly suggest making a new material and label it test cut matrices, something like that, and create a new material settings. So let's call this power cut test with intervals labeled. And what we want to do is for each color, we want to turn on cut CO2. And we want to do that for all 16 colors. And once everything is activated, we want to put the power values that matches our matrix. So it starts at 50, 51, and it increases by 3. And then you do it for everything. So in the end, you will have something that looks like this. So I already did everything, as you can see. I did all the legwork beforehand, so I could just plug and go in the future. So it's very important that your power setting matches the intervals over here. You also want to keep speed the same. You can determine this yourself. You can either pick, 0.9 speed, 1 speed, 1.2. Make sure everything is the same variable. Once you start changing the power variables and speed variables, things become a bit more complicated. We don't know which setting is causing what, so it's very important to just change one setting at a time. So if we're testing for power cut, only power variables vary and everything is the same. Okay, this looks good. We have our parameters set. So let's hop back to our file once again, and we are ready to send this matrix to job control. So I'm going to go to File, scroll down, Print or Control P for a shortcut. So we're going to wait for the window to pop up, which will take a few minutes. It's quite a large file. All right, so once the print window pops up, make sure you have your Trotec engraver selected in your printer. You want to make sure your artboards is selected range, and because I want to send this matrix, which is artboard number 6, I have a label number 6. If you want to send speed cut matrix with this interval, you put number 9. That's why I labeled each artboard their number, which corresponds to the artboard number. And all your other settings should match mine over here. So let's go to Setup, Preferences. So the canvas size is 3.38 by 2.75, which is the size of the matrix. You can choose to minimize the job size, which will remove all the white space at the top, bottom, left, and right. It's based on your preference. Next, we want to select the material settings over here. This is very important. Remember the parameters we set up, so we want to select that. Make sure we have the correct process mode activated. Sorry, my material database is a bit squished. Yeah, so we want to make sure that the process, all the colors is turned on for cut CO2, not engrave. This is very important. If you click engrave and you try to cut, it won't work. So your process mode should be in standard. Because we're just cutting wood, 500 dpi resolution is fine. But if we're testing engraving, resolution will play a factor. I'll go more in detail later on. No cut line. Make sure your halftone is in color mode. If it is not in color mode, it will convert all our color 16 RGB color values into grayscale. Select enhanced geometries. Inner geometries first, and we're good to go. So press print, and there we go. We have just sent our matrix to job control. Once we sent our matrix to job control, we could place it on the plate. To ensure that our file is being properly read, you could go to View, Vectors. And what happens is when you select your job, it should be able to read all the vector values in your file. When your file isn't being correctly read, it will look something like this. And when you select it, nothing will appear. So the parameters are set and everything. But as you can see, none of the vectors are being picked up with this tool, which meant your parameters weren't set before the file, or your stroke line wasn't set to hairline, or the color values are incorrect. It could be any of those 3 factors. So make sure you double check your file before you send it. All right, so once we place our job onto the plate, double check our parameters, looks good, and we're good to go. Alright, so let's learn how to use these material parameter matrices to test on your own materials. So for example, let's say we want to do a test cut on Trotec 5mm maple wood. Before we select a matrix, I'm actually going to hop back into job control, go into material database and look for a setting, a recommended setting for what I'm cutting with. So let's go to solid wood, and there is a setting for 5mm maple. So I'm going to look at these parameters and see what they're using as a guideline to pick my matrix later on. So as you can see, the settings are telling me to cut at 100% power with a speed of 1.4 and 1000 Hertz. With this information, I'm going to go back to my file and look at the matrices that are available. So over here, there are 3 different power cut matrices. Just by observation, it seems like the matrix over here has the intervals that best matches the power settings that I'm looking for, something with a higher power cut. And it seems like this matrix will give me more information for the material I'm working with. The one in the middle uses pretty low power settings. This seems like a good matrix for thinner materials or softer materials such as paper, troll lace, or fabrics. There is also a general power cut test with a low power settings, medium range power settings, and high range. This is good for experimental purposes if you want to see what will happen to material with a low, medium, and high power cut. So before I send this matrix over to job control, what I want to do beforehand is actually set the parameters for the matrix before I send the file. So what I want to do is create a new group. This is actually highly recommended for people. You don't have to, but I highly recommend it. Is to create a new group called something like matrices S, or anything you like. And under this group, I'm going to create a new material called cut power test with the intervals like so. And for each RGB color values, I want to turn the process mode to cut CO2. So I want to do this for all color values. And I want to make sure the power settings matches the intervals displayed in my matrix. So I know it starts at 51 power and it goes up by 3 intervals. And like so. In the end, you have something like this completed. As you can see here, I made a specific group with a bunch of parameters for different matrices. That way I could just pull in the file, plug it in, and run the job quickly, and I don't have to every time click and fill this up. So we want to make sure that our power variables matches the matrix intervals over here. We also want to make sure that all the other variables are constant, such as speed, hertz, z offset, and passes are all the same. We don't want to be changing multiple variables at the same time. That's when it becomes very complicated and we don't know what variable is doing what. So we want to isolate it. So once we have the parameters set, let's jump back into CorelDraw. So as you can see, we're working with a big canvas with a bunch of file details. I am going to select this matrix over here, it's grouped right now. This is actually one of my favorite features of CorelDraw that isn't included in Adobe Illustrator. So where I want to go is print this file. So let's go to preferences. And let's determine our canvas size. So the size of the matrix itself is 3.38 inches by 2.75. You can choose to minimize the job size, which will remove any white space on the top, bottom, left, and right corners. This is optional. I'm going to keep it unchecked. In our material settings, we want to select the parameters that we created in job control. And we want to ensure that our process mode is activated on cut seal 2. So if we're doing a cut test, we want to ensure that the cut seal 2 is on. If we are doing an engraving test, we want to make sure the process mode is in engrave seal 2 for all of them. If this is wrongly selected, the file won't be read correctly on job control. So this is very important to ensure that our file is working properly. So once we have our material settings selected, our process mode should be on standard. Cutting wood with 500 dpi is fine, but once we test engraving, dpi for resolution plays a huge factor in quality, which I will later go in depth. Cut lined, we don't want any. We want to make sure the color mode for halftone is selected. If not, it will convert all our beautiful 16 RGB colors into grayscale, and then our file won't work. We want to select enhanced geometries first, select inner geometries first as well, and we're good to go. So remember how I said select your file before because of this feature. Right now, our preview, we're not getting our matrix. So what we want to do is go into print range and click on selection. So this is really awesome because for me, I like to work in a big canvas and select only parts of it that I want to cut or print. And make sure we go to layout and reposition image center a page. And then we're good to go to print. Once we sent our matrix to job control, we could place it on the plate. To ensure that our file is being properly read, you could go to View, Vectors. And what happens is when you select your job, it should be able to read all the vector values in your file. When your file isn't being correctly read, it will look something like this. And when you select it, nothing will appear. So the parameters are set and everything. But as you can see, none of the vectors are being picked up with this tool, which meant your parameters weren't set before the file, or your stroke line wasn't set to hairline, or the color values are incorrect. It could be any of those three factors. So make sure you double check your file before you send it. All right, so once we place our job onto the plate, double check our parameters, looks good, and we're good to go. So here are the results from running 3 different matrices, testing power cut settings, engraving power settings, and Z offset engraving. So let's take a look at the results for the power cut test. So I ran this test at 1 speed, and as a result, we can actually get away with cutting this material with 72% power at 1 speed. We don't necessarily need 96% power at 1 speed. I think that's a bit of an overkill. Or what we can do is actually increase the power and also increase the speed to say 1.1 speed or 1.2. That way we could run the job at a faster time. So the next, let's take a look at the engraving. As you can see, it's very faint, but we don't get any results when we're running at a 30 or 25% power. We start to see an engraving effect once we hit around 40 and 45, but it's still a bit faded. We get a nice contrast around the 55 to 70 range. It's nice and clean. Once we hit the higher percentage power, it gives us a nice contrast, but we also get this burning edge. So what I also tested was the Z offset ran at 75% power and 100% speed. As you can see, the more you increase the Z offset, the darker the engraving contrast you get. But as you increase the Z offset to 0.1, we lose a bit of detailing in the font. So by running these three matrices, we get a lot of information on what kind of settings we should use to cut or engrave wood. All right, so I also ran some tests on our Troll Glass casted acrylic in 6mm. This is about a 1/4 inch thick. So the first test I ran was a cut power test. I want to see what my settings were to cut through 6mm acrylic. So I ran this test at 1 speed, and I actually didn't cut through the material even at 96% power. So what that's telling me is I have to slow the speed down so the laser will cut through the acrylic. So what I did was I picked 93% power and did a speed cut test. At 93% power, cutting at 0.1 speed, it cuts through, and I can cut through it with 0.45 speed. But once I hit 0.5 speed, that's when it doesn't cut through. So what this is telling me is I could run this test again and cut with 93% power at 0.45 speed. It's not necessary that I use 0.1 or 0.15. I think that's a bit too slow and I get a lot of burning. So around this range is good for a nice clean flame polish cut. The next test I did was an engraving power test. So what I did was I ran the engraving test at 100% speed. As you can not see, you don't get any of an engraving effect with a low power. I believe this is but 20% and 25%, you don't get any detailing. Once you hit around 40, 45, you get this nice surface edge. And when you hit around 50 and 55, you get a more contrast of an engraving. Once you increase the power, instead of a surface edge, you get a little depth with the etching. The problem with that is with the depth, residue tends to get trapped around these areas. So it's always important to find the right settings to get a nice surface edge, and we don't want to go too deep into the material. The final test I did was a Z offset using 55% power, and I did autofocus engraving to see what happens. As I increase the intervals, the engraving becomes a bit more faint. But what it's also doing is the beam is picking up any of that acrylic dust that is being created from the engraving. So if I keep going out of focus, it actually cleans it a bit, but we lose some of the detail. Here's another photo to show you some of the details and what's happening with the Z offset. So I also ran some tests on Trolley's 1.6mm in blue-white. The first test I did was a power cut test, ran at 1 speed. I did a low interval cut power test because I know Trolleys is pretty thin. I don't require a lot of power. As you can see right here, I need about 39% power to 48 at 1 speed, or this is telling me I could either increase the speed, so at 1 speed and 39% I could cut through, or I can increase the speed to 1.1 and use a 45% power and it should cut through. I can do another test to prove that concept. Next, I did an engraving power test. You can see at the very top with 20% engraving power, you don't get much of an etching. Once you start to use 35%, you get a surface etch, but the detail is lost. Around 40 to 50%, you get a nice white engraving that is just surface engraving. But once we use too much power, that's when we get all this white residue from engraving the white instead of the blue, and it makes trolleys quite difficult to clean. So what we want to do is actually find the minimal power, which is around 50 or 55. So that's what I did here. For a Z offset test, I used 55% power and 100% speed, and just to see what happens. There's not much of a difference when we increase the Z offset by 0.01. You get, I guess, a more white finish because it cleans off any of the blue residue that may bleed onto the white. But once we hit around 0.08, the blue starts to bleed into the white. So if you add a little Z offset, you could actually clean the white spot as you're engraving. Pretty neat, right? A bonus tip: with the pen or Sharpie, jot down any notes onto the matrix, such as the machine used, the lens used, or any fixed variables to help you document the process. Tips for cutting wood. You want to use 333 or 500 dpi. You want to cut at a low frequency level, such as 1000. Denser woods require more power, such as alder, balsa, beech, wood, oak, and walnut. Softer woods require less power. For example, MDF, cedar, pine, and spruce. But please also consider the thickness of your material, which plays a factor in your parameters. Pointers for engraving on wood. For any engraving job, use 333 dpi. You can increase the engraving contrast by increasing the Z offset value. Engraving on wood produces a lot of dust, so if you're doing large jobs that require a lot of engraving, you may want to clean your lens or machine quite often. Use masking tape to reduce any of the smoke marks caused by the heat from the laser. Tips for cutting acrylic. Use 500 dpi. When cutting acrylic, use medium to high frequency levels. Increase the frequency for thicker acrylic to create a nice flame-polished edge. Mask the bed to increase draw and reduce flaming. Use a 1/4 inch diameter nozzle. Focus the laser head 1 mm to 2 mm into the material for every 10 mm thick material. Use the 1/4 inch diameter nozzle. Tips for engraving on acrylic. You want to use 500 to 600 dpi. Your engraving direction should start from bottom up. Increase the Z offset to clean any of the residue or engrave clear for clear acrylic. On clear or dark acrylic, invert your colors for a better contrast engraving. When engraving, you want to use minimum power to etch the surface without creating excessive residue. If engraving acrylic oftenly, please keep in mind that you may want to clean your lens or machine more often. Tips for cutting Lamacoids. Use 500 dpi. Use a low frequency, like 1000. When cutting multiple pieces, do not cut all the way through. This will allow you to easily clean the whole sheet and snap off the pieces. Tips for engraving on Lamacoids. Use 500 dpi. Increase the Z offset value to create a higher contrast engraving. A lower speed and power will reduce the warping of the material. Thinner materials tend to warp easily with more heat applied. Therefore, use a flat cutting table and double-sided tape to prevent the material from bowing upwards. Use minimum power to remove the top layer of any 2-ply Lamacoids. Engraving too deep would create excessive residue and color bleeding.